Albert Einstein sat alone in his study, the sky outside his window growing darker by the minute. His thoughts were heavy, not with triumph, but with the quiet weight of doubt. For all his genius, he couldn't shake the moments when even he felt uncertain, standing at the edge of the vast, unknowable universe. In 1915, Einstein had crafted the groundbreaking equations of general relativity. But those same equations revealed an unsettling truth. The universe couldn't just sit still. It had to either expand or contract, like a song that could never rest in silence. Einstein didn't want to hear it. To him, the cosmos was eternal and unchanging, a steady backdrop to everything else. So, he did what few would dare. He altered his own equations, adding something he called the cosmological constant. This tweak kept the universe frozen in place, just the way he thought it should be. Years later, Edwin Hubble came along and shattered Einstein's tidy picture of the universe. Hubble's observations showed that the universe was, in fact, expanding, and Einstein's constant wasn't needed at all. Looking back, Einstein called it the greatest blunder of my life. But here's the twist. Long after his death, scientists found new reasons to bring back his cosmological constant to explain dark energy, that mysterious force driving the universe's expansion. It's as if Einstein had unknowingly stumbled onto something far ahead of his time. Then there was quantum mechanics. In the 1920s, it was turning the scientific world upside down, with strange ideas about particles existing in multiple states and unpredictable behaviors that defied logic. Einstein hated it. How can the universe run on chance, he would demand. For him, the idea that uncertainty could be baked into the fabric of reality was unbearable. He pushed back, and in 1935, with two collaborators, Einstein wrote a paper trying to expose the flaws in quantum mechanics. He introduced what we now call the EPR paradox, arguing that the theory must be incomplete. He couldn't accept the idea of spooky action at a distance, where particles seemed to influence each other instantly, no matter how far apart they were. God does not play dice, he famously declared. But the universe had other plans. Decades later, experiments showed that Einstein was wrong. This spooky action was very real. Still, his skepticism pushed scientists to dig deeper, and in a way, his resistance only made quantum mechanics stronger. His mistake became part of its story. In his later years, Einstein turned his focus to a dream he couldn't let go of, finding one equation that could unify all the forces of nature. He wanted to merge gravity and electromagnetism into a single, beautiful framework, a theory of everything. If we can discover this formula, he said, we will understand the mind of God. But by then, physics had moved on. New discoveries about nuclear forces, strong and weak interactions, were reshaping the field. Yet Einstein didn't engage with them. He kept working on his unification theory, alone and increasingly disconnected from younger physicists who were charting new territory. Despite his brilliance, he never found what he was looking for. When he died, his papers were filled with unfinished equations, his greatest dream still out of reach. Even before all this, Einstein had struggled to accept that the universe itself might be dynamic. Early in the 20th century, a mathematician named Alexander Friedmann had solved Einstein's own equations and found that they predicted a universe that wasn't static. Einstein dismissed it outright, calling it nonsense. A static universe was what made sense to him. But then Edwin Hubble's telescope showed otherwise. Galaxies were moving away from each other, proof that the universe was expanding. Finally, Einstein had to admit he'd been wrong. Visiting the Mount Wilson Observatory, he reportedly sighed and said, "At last, I believe in my equations." For all his mistakes, Einstein never stopped exploring, questioning, and reaching for something bigger. His errors remind us that even the greatest minds don't have all the answers. And maybe that's the point. Each of his missteps opened doors to discoveries he couldn't have imagined, inspiring the scientists who followed him.